Hello there everybody, Sam Strains here, welcome back to the Railway and welcome to another sort of tutorial video. Now today I'm going to be discussing something that people have been asking me for a long time and it's something I've never done. So this is going to be my guide to DCC. Now admittedly, I mostly use DC when I'm using my Railway just because it's a little easier. However, I have to admit that even though I use DC most of the time, there are lots of advantages to using DCC. So it's something that you may well want to consider, even if you don't end up picking it in the end. So today I'm going to start off by explaining pretty scientifically actually what DCC is, and that hopefully will help you understand whether or not it's something you need. And then second of all, I'm going to talk about the actual advantages of DCC over more conventional DC methods. And then thirdly, I'm going to actually just get a bit practical and just show you DCC in action, show you two of my DCC systems, that is the Select and the Hornby E-Link. Those are two of the cheapest, most affordable, but most effective controllers you can get if you're a beginner and just want to sort of dip your toe in the water. So let's get started then. Here's a brief, well it won't be too brief actually, I'm going to go into some detail because I find it quite interesting and hopefully you do as well. So an explanation of what exactly DCC is and how it differs to DC. Here we go. So first of all then, let's consider what DC is. Regular, traditional DC, as has been used for many years. Now at heart, all of our locomotive motors run on DC current, that is, direct current. None of them differ in that regard. Even the ones that are DCC fitted, their motors still are DC. Now regular DC controllers just put out direct current and it looks like this. So if we turn the controller up in the forwards direction, this is what the voltage looks like. And pretty much the voltage going into the tracks is going to be proportional to the speed of the locomotive, right? And you know this, you turn up the controller, the locomotive gets faster. That's how it's always worked. And effectively, when you stick a locomotive on the track, when it's DC operated, you're putting your locomotive in series with the controller, right? That's what it is electrically. Now, if you add a second locomotive, for example, you're putting that locomotive in parallel with the other locomotive. That is, they will both see the same voltage, and they will both draw whatever current they need from the controller, providing it's capable of putting out that kind of current. Now, the fact that both locomotives see the same voltage leads us on to our first disadvantage of traditional DC. Because as you can see, when we apply power to the rails there, both locomotives will run at the same speed in the same direction. There's absolutely no independent control. Now that is quite limiting, of course. You probably won't be able to run two locomotives on the same circuit. If you double head, well, that's less of a problem, but you still need to use two locomotives which have similar speeds at similar voltages. Otherwise you'll end up with one locomotive just dragging the other or pushing the other, as can be seen here, and it's certainly not ideal. So that's the first issue. The second major issue of regular DC comes from voltage drop. So any length of track has a resistance. Now this isn't necessarily essential in understanding the differences between DC and DCC, but bear with me because I thought this would be quite interesting. So you can actually calculate the resistance of a length of track. So the resistance R, we're going to use R here in ohms of course, is equal to rho L over A. Now rho is the resistivity of the material, and in this case I'm using nickel silver track, and the resistivity incidentally of nickel silver is 2.87 times 10 to the minus 7 ohm meters. Just bear with me if you don't know what that means, that isn't too important. L of course is the length of the track, but of course we're talking about track here. The current has to pass up one rail, through the locomotive and then back to the controller. So for the purpose of this we can double it. And then A of course is the cross-sectional area of the track, and with double O gauge track, my double O gauge track, that is approximately 1.125 times 10 to the minus 6 meters squared. And again, this is pretty complex stuff, but effectively if we choose then 5 meters of track for example, that gives us 2.5 ohms, which is really quite a lot of resistance over just a small 5 meter stretch. My track, for example, is a good 10 metres, maybe more. So it is quite significant. And in practical terms, what that means for your locomotives is as they get further away from the controller, they will slow down. That is, energy is being wasted through the tracks in the form of heat, if you like, and you will lose some of that energy going to the locomotive. In other words, if you've got a big circuit of track, you will see the locomotive slow down, sometimes quite dramatically as it gets further from the controller, and equally it's going to speed up quite a bit as it gets closer to the controller. Now, obviously in a small loop of track, just like the ones you get with these Hornby train sets for example, on DC the voltage drop and the resistance is going to be so unnoticeable, it's really not going to be an issue at all. So unless you want to run multiple locomotives on the same track independently, then DCC is not necessary for smaller layouts in that sense. However, with bigger layouts like mine is a huge circuit of track, that voltage drop is a lot more apparent, and if you want to run DC, you'll probably want to add some extra inputs to the track like I have done over here at the other side of the room. So what's happening here is that resistance is making the voltage drop. So if your controller's putting out, say, 12 volts, a long way away from the controller, the locomotive may only be seeing, I don't know, 9 volts or something like that. It does make quite a difference actually. Although of course, bear in mind if you're using a circuit of track, at the furthest point from the controller you can half the value for the resistance because effectively you're doubling the cross-sectional area. Anyway, let's not get onto that. So effectively the more current you have, i.e. if you're double heading for example, you'll be pretty much doubling the current through the rails, the more the voltage is going to drop. So that is DC operation, and typically a DC controller will output anywhere between 0 volts and 12 volts. Of course 1, 2 and 3 volts denotes the super slow speeds, and if you ramp it up to 12 volts you'll get the high speed. So that is DC, direct current. Now DCC is quite a bit different to this. First of all, it isn't just direct current. DCC uses a form of alternating current, so the current flows in different directions, and your DCC controller will vary the frequency of those waves in order to transmit data. Now obviously our motors in locomotives cannot run on AC signal, it just makes a noise and they won't go anywhere. So what we have to have is a decoder which goes in between the rails with this AC current in them and the motor which requires DC. And basically all that happens is those decoders will literally decode the signal coming through the track and they will output a DC signal just like your DCC controllers do, except of course rather than having 5 meters of track or whatever where the voltage drop occurs, you're talking centimeters of wire going directly to the motor. Now the DCC output from the controller is quite a bit higher than the voltage that comes out of a DC controller. As we said, the most that will come out of a DC controller is 12 volts, whereas my Hornby Select controller, for example, puts out 15 volts. Now it always puts out 15 volts, regardless of the speed the locomotive wants to run. The decoders in the locomotives will always receive that 15 volt AC signal, and they will just convert that into whatever voltage they need in order to power the motor at the correct speed, okay? So you've got a much higher voltage running through the tracks at all times, which means that when you run a DCC locomotive you won't see any of that slowing down because there's a lot less current in the track at all times. So let's think about this. So say we want to run a locomotive at 3 volts, right? That's quite a slow speed for a locomotive. So on DC we need 3 volts going through the entire track, of course, and most locomotives run at 0.2 amps, that is 200 milliamps. So when a loco like that is running at 3 volts and it's drawing 0.2 amps, we can say that it's running at a power of 0.6 watts. And when we're running on DC mode, we've got that 0.2 amps running through the rails at all times. Now on DCC that motor is still going to be dissipating 0.6 watts, but because that power is being transmitted through the rails at 15 volts this time, you've got 0.04 amps, that's 80% less current running through the tracks. And as we figured out earlier on, the more current through the tracks, the more voltage drop, the less current going through the tracks, the smaller the voltage drop. So you've got a tiny amount of voltage drop. Now at max speed at 12 volts, obviously it's not going to be quite as efficient, you've got a bit more current running through the tracks on DCC here, but it's still around 20% more efficient than it would be on DC, because obviously the most we use on DC is 12 volts. So all you've got to understand is that DCC decoders are capable of putting out a constant regulated voltage to the motor in a locomotive, regardless of its position on the track. And in fact, a DCC locomotive can get a really long way away from a DCC controller before it starts to lose speed and slow down. And of course, you can calculate this. If we assume the minimum voltage our decoder needs is 12 volts, that means we can drop 3 volts from 15 before we've got trouble. So if you work that out and we substitute it into the R equals PL over A equation and rearrange it slightly, you get approximately 30 meters before we start to see problems. Now in practice, of course, that's probably an overestimate because, of course, most layouts have points and things, they have fish plates, all of which act, if you like, as bottlenecks, and they increase the resistance too. But certainly if you got 30 meters away from your controller on DC mode, you would see a lot of slowdown and a lot of problems. And of course that also makes the assumption that decoders require 12 volts. They may need a little bit more, I'm not too sure. So in a nutshell, that is the first major advantage to DCC. You get consistent running over longer distances compared with DC. The other advantage, of course, is multiple locomotives. We're using a digital signal here, so the decoders will only power their relevant motors when the controller tells them to do so, which means we can have multiple locomotives on the same track going in different directions, because it's AC, it doesn't have a direction. So you've got a lot more flexibility there. You can independently power as many locos as you like on the same piece of track, provided of course your power supply and controller are capable of putting out that kind of power. So those are the advantages of DCC. If you think you can make use of those, then perhaps it's the way to go for you. But for now, let's talk practically about what DCC can do for us. So that is the science of DCC out of the way then. So now let's talk about it in practical terms, what you need to get started with DCC. So as I've already mentioned, the traditional DC controllers won't cut it, so you will need to get a DCC controller. Now this particular controller is known as the Hornby Select. It's one of the cheapest DCC controllers available. It's also one of the most basic, but I can recommend them. If you're looking to just start out, if you're looking to just control locomotives, obviously DCC does have the capability to control points and signals and other accessories, but if you're looking to just start out with locomotives, then the Select is a nice and simple controller which will do that perfectly. However, regardless of the controller you use, they all work in pretty much the same way. Of course, they all have slightly different interfaces, but they will all do the same job. So shop around, get recommendations. I can recommend either this or the Hornby E-Link and Railmaster, or equally the Hornby Elite is pretty good as well. But there are a lot of good controllers out there which are worth checking out. But if you're looking to just start off and you want to just control basic no sound locomotives, maybe with a few lights or whatever, then the Select is just fine. The second thing you will need then is locomotives that are compatible. Now this here is a DCC fitted locomotive, and you can always tell a DCC fitted locomotive by the packaging. It will always say DCC fitted, and basically all DCC fitted means is that the DCC decoder, this is one of the decoders that I mentioned earlier, it means that one of these is already fitted inside of the locomotive. But of course a lot of the time manufacturers don't sell locomotives DCC fitted, and some of the time you'll have to do it yourself. Now this leaves you with a couple of options. Now it's safe to assume that most modern locomotives, at least the ones we buy from Hornby, Bachmann, Helgen, etc., it's safe to assume that all of those are going to be DCC ready, but you can check by just looking at the end of the box. This is a Hornby box, this shows that in blue there, this is DCC ready, and this is a Bachmann box, this shows in black that this requires, I think, a 21-pin DCC decoder. Now there are different decoders out there. This particular one I've got is an 8-pin version, but a lot of the Bachmann stuff take 21-pin decoders. Now if you're confused about all of this and you don't want to do it yourself, take a look at Hatton's, for example, because you can just order a locomotive from Hatton's and you can have them chip it for you with a decoder that they recommend. If you're willing to do it yourself, you can buy the decoders, you can save a few pence, for example, and you can fit the decoder inside the locomotive. Now DCC ready locomotives will have a socket inside. All you do is you take your decoder, you literally plug it into the socket, and in this case you would need to plug in the wire to the decoder itself, and Bob's your uncle, you're ready to go. If you're not confident to do that, then as I say, there are services out there, such as Hatton's for example, which will do it for you. Now lastly, if you want to use your layout exclusively on DCC, you're ready to throw away your DC controller and use only DCC, then you do have the option to upgrade your points as well. Now if you decide not to do this, your points will work exactly the same as they do on DC. That is, you can only control a locomotive with them if they are set to accept that locomotive, for example. But obviously with DCC we're talking digital signals here, so you can actually have it so that your points are completely live. So for example, if we've got power going in here, you can have live this way and live that way, and because it's DCC you can power a locomotive even if the points are shut against it. You can do that by buying DCC clips. Do a little bit of research into that if you're interested, but if like me you're planning to switch between DC and DCC, then I don't recommend doing that, and certainly that's not something that I've done. But if you're using solely DCC, you can do that. So that is really all you need for the basics. Obviously if you want to really do the thing properly, you're going to want to set up signals and points, and that isn't this video. This video is just basics. But for locomotive control on DCC and to get started and really find out whether you like it or not, this is all you need. So let me show you then how you actually go about using this sort of tech. So here's a little bit about using the DCC Select. I'm going to talk about Railmaster and E-Link as my second example in just a moment, but for now let's talk about the Select. So let's imagine then that you've just been to the shops or whatever and you've picked up a brand new DCC Select controller, and as you can see here I've plugged this in and I've connected it to the track. Let's also assume then that you've been out and you've bought a locomotive. Here is Mallard here. Let's pretend it's brand new, straight out of the packaging. So every DCC decoder has a number, and we call this number the address. And this address basically allows the DCC controller literally to address a specific locomotive. Now, when you buy a locomotive from the shop with a DCC decoder inside, the default value for the address is number 3, as you can see here, and quite conveniently, when you plug in the select, you get number 3 selected already. And so if I give this a little bit of juice, set it up to half speed, you can see Mallard there creeps forward. Now, if you've just got the one loco, I don't know why you'd want just one, you might as well use DC, but imagine you've just got the one loco, that's all you'd need to do, there wouldn't be any more setting up. You control direction like this, so you hit the other button here, and give the loco some power, and as you can see it goes in the other direction. That's all it is, but let's imagine now that you want to add a second locomotive. Now let's bring in the Flying Scotsman then. Now if the Flying Scotsman was brand new as well, you would then have 2 locomotives set to number 3. And so if you power them both, for example, let's try this, you can see that the Flying Scotsman kicks into life as well as Mallard, and obviously that's what we're trying to avoid by going on to DCC. So now let me explain then a little bit about addressing of locomotives. So locomotive decoders have a list of CVs. Now CVs we don't have to really explain too much, but just imagine each CV as being a fragment of memory that these decoders have. So as you can see here, if we take a look at the Hornby instructions, we do have a list of these CVs. So you can see that CV1 here is the primary address, and as I've already mentioned, the default value is 3. So by changing CV1, we can change the address. But interestingly, by looking at this, you can see we have more than one option here. So we have acceleration rate, not CV3, default value 5. So that means that you can change the way in which your locomotive accelerates. So with a CV value of 5, for example, if I set the locomotive to half speed, it will take 5 seconds for that locomotive to reach that speed. And if we change that CV to 10, it would then take 10 seconds, and so on. You can have really slow acceleration. Just underneath there you can see the deceleration rate is CV4, and that's also set to 5 by default, which means when we turn off a locomotive from whatever speed, it will take 5 seconds in total for the speed to decline to 0. Now you've got a few other bits and bobs on here. You've got the manufacturer version, blah blah blah, manufacturer's ID, blah blah blah. You've got all sorts of other stuff, but really if you're just starting out, the primary address, acceleration rate and deceleration rate are all you need to talk about. So let's talk about then how we set some of these values. Now unfortunately the DCC Select, the one I've got here, doesn't make it very easy to change some of the CVs, but luckily the address, the acceleration rate and deceleration rate are quite easy to change. So let's imagine then that I want to change the number of my Mallard to say number 1, and then I've got the Mallard on number 1 and the Flying Scotsman on number 3. So the first important thing to do is remove the Flying Scotsman from the track, because any loco on that track, when we do the programming, will be affected. So if the Flying Scotsman and the Mallard were on the track while I did this programming, they would both end up with the number 1, which is not what I want to do. So with the select, all you do is you make sure that the only loco you want to program is the only loco on the track. You hold down the select button like this, and you press 1. Then you hit select, and the job's done. You'll see a little red light flash like that for a bit, and now if I change the speed, we can see that the Mallard is now controlled. Okay, so let's return the Flying Scotsman to the track then. And now if I turn up the power, you can see that it's still only Mallard that works. If I want to operate the Flying Scotsman, I'll have to press my number 3 here, press select, and then I'm free to power the Flying Scotsman like this. There we go, perfect. Okay, so how do we change, for instance, the acceleration and deceleration rate? So once again, I'm going to take the Flying Scotsman off the track and bring Mallard back into shot for you. And this is what you do. So you hold down the function button and one of the direction buttons at the same time. So let's do that. You then see that we have selected deceleration. So let's say we want it to take 10 seconds, select, for the locomotive to decelerate. So if I do that now then, let's select number 1 and speed it up, and now let's cut the power, and as you can see it glides quite nice and gently to a stop, which is exactly what we want. So let's change the acceleration rate then. Let me hold the function button and the other direction down, and let's set that to something crazy like I don't know, 30, and see what that does. So that will do the programming. There we go. Now let's set that to accelerate towards us. And as you can see, she's taking quite a long time now to speed up. And that might be desirable. But as far as I'm concerned, that's really all the Select is good for as far as programming goes. And basically, that's it. That is your lesson on the DCC Select. So now let's talk about Railmaster then, and the pros and cons of that. Okay, so here is the E-Link controller then, and as you can see, it looks quite a bit different to the Select. There aren't any buttons or anything on this one, and that's because you can't use this controller on its own. However, I've set it up just as I did with the Select. It's plugged into the 15-volt power supply which came with it, and it's also connected up to the track, as you can see. Now this controller is actually connected to a computer via USB cable. It's a USB controller, and on this computer here, as you can see, I have Railmaster installed. Now I'm not going to go through the business of installing Railmaster and such because it's relatively simple, but there is quite a process of getting all the drivers installed, but it's relatively simple. It doesn't take too long. Okay, so as you can see, I have some locos installed on here already. You'll just have to ignore those. Normally when you install it cleanly, you won't have anything here. It'll just be empty, ready for you to add your locos. And then on the left hand side here, as you can see, you've got a track plan. This is the sample track plan that comes with the program. But actually this software and the E-Link controller do have the power to very easily control signals and points and things, and this sample track plan is to demonstrate that. And certainly if you want to, use points and signals and things on your layout, then you can go through the track design system and set all that up. But for me personally, I just use this for locomotives, and to keep things relatively simple today, I'm just going to be doing that. Okay, so let's put our Mallard back onto the track then, and if you remember correctly, she is programmed as number 1. So what you do is, to get started, once everything's up and running, you can click this Set Up Locomotives button here, and it will initialize the list of locomotives, and once that's done, we can get into there. And all we can do here is that we can add a locomotive to the database. So if you remember correctly, the number of Mallard was 1, so I'm just going to put in 001 here. There we go, and then you can look for a name. You can name the loco, and actually Hornby have a good search option here. This will only work with Hornby locos. If you want to add a Bachmann loco, that's fine, but you won't get an image of it unless you add your own. So anyway, let me put in Mallard. Okay, I'm not too bothered about which version I pick here, but you can go through and find the exact right version. But I'm just going to pick a BR green one here. And as you can see, it sets up defaults for the A4. So we've got the cruising speed in miles an hour here as a default is set to 90. And the shunting speed there is set to 10. And I'll show you what that involves in just a second. But for me, that looks absolutely fine. So I'm going to click the tick just here. And now I'm going to X this off. And now we have Mallard entered into the system. And if I scroll through my list of locomotives here, there it is. I can see Mallard there on the bottom right hand side. So all I'm going to do is grab this slider with the mouse and turn it up to about 25 miles an hour, and as you can see, the model starts to move. Absolutely fantastic. You've got direction controls here. It works very much like the Select does in terms of performance. Now if you've got a digital sound locomotive, for example, here is my Earl of St. Germans. If I can double click on that, you can see it does bring up a bigger controller, so you can control it with this. Earl of St. Germans isn't on the track at the moment, so obviously nothing's happening there. For some reason the sound options have disappeared from here, but these are the functions, so it's literally just a case of clicking on them. And if you look here, you actually do have the sound option here, so if I click that, that turns the sound on, and then you've got a few basic functions here, but if you want the rest of them, oh, here they are, they've appeared now. If you want the rest of them, you have to double click. I don't know what's going on here. As I say, I always find that Railmaster's a little bit glitchy. That's one of the downsides. There are quite a few glitches, but in fact I recently completely wiped this computer and reinstalled everything, and that has made it a lot better. But yeah, as you can see, you've got a list of all the different functions here, so you can use the sound. Okay, so supposing then, just like you did with the Select, you want to change the number of the Mallard. Now it's not enough just to go into the locomotives database here and simply change the number. So suppose I want to change Mallard back to number 3. It's not good enough just to choose Mallard here and change the number. So if I change it to 3, for example, there, and save it, Yeah, that's fine. But that won't really change anything in the decoder. As you can see, Mallard here is number 3 now, but that only means that Railmaster, when I turn the speed up on here, Railmaster will just instruct decoder with the address number 3 to speed up, but that isn't Mallard because the address of the decoder is still set to number 1. So how do we change it? Well, first of all, you have to connect the loco to the programming track. Now, if you don't have a programming track, that's fine. You can just switch the track connectors over to the programming side. But again, you'll have to make sure that there are no points or anything or any other locos connected at the same time. And really, that's why there is the programming socket on here, because it's expected that you have decoders such as point decoders and signals and things connected to the power supply all of the time. This way, you can just have a programming track to do all your programming on. But in this case, the only thing connected will be my BR Green Mallard, so that's just fine. So now what I can do is I can go into the locomotive database again. Let me just load this up. There we go. I can hit this information button here now, and it will bring up a list of CVs. So this all looks pretty complex, but if I just zoom in here, I'll show you exactly what's going on. Now this is a huge advantage over the selectors as far as I'm concerned, because as you see, we've got a whole list of different CVs here. Now obviously, once again, the only ones we're really interested in here are the locomotive address, the start voltage, the acceleration, the deceleration. I suppose start voltage is quite good. That's if you DCC fitted a triang loco, for example, and you didn't want it to be stalling at low voltages, you could set that. But bear in mind that only some decoders will support some of these different options, and specifically the cheaper Hornby decoders don't support a lot of these options. So what I'll do then is let us collect some CVs, let us get it to read out some CVs on this decoder. So what I want is, let's take the locomotive address, the start voltage, the acceleration, the deceleration. So that is CV 1 to 4. So if I change these values here, so we want 1 to 4, and then we can choose Get CVs, which is the tick. It's a little bit of a strange interface, this. There we go. So now what it will do is it will read those 4 CVs, CVs 1 to 4, and assuming the decoder supports them, we should get some values. So there we go, there's the first one, and yes, as we did with the select, you can see that the locomotive address is at 001, that's the current address. We can see the start voltage is 0. I'm not too sure whether the Hornby decoders support that, so maybe I won't be able to change that, who knows. We can see that the acceleration is at 5, which is how I set it in the end, and I also reset the deceleration back to 5, so that should still be true. Okay, so now then, let's try resetting the locomotive address back to 3, which was the default, of course, and I've already changed that in the Railmaster database, so let's do that now. So let's change 001 to 003. I think we'll leave the acceleration and deceleration where they are, because that's not a big deal. And so what I'll do is I'll just set 1 to 1, because we're not interested in CVs 2, 3 and 4 anymore. And then all I'll do is just press write CVs to loco, and all that's doing now is it's writing 3 to the address. So it's writing that one, and then there are some extended address CVs, as you can see that it's writing down below. You never have to touch those, Railmaster always seems to do that just fine, so there should be 3 of those. So that's 1 done, and it will confirm it, so it gets the loco to read back what it's written, just to confirm it. That's 2, and then the last one, confirming. There we go, it's done. The loco is now renumbered to number 3, so I can X that off, and I don't need to save anything here because it's already been sorted. So yes, I'll abandon the changes. Now don't forget, I've got to disconnect these wires from the programming track and reconnect them to the locomotive power track. And now if I give Mallard some power, she should move. Okay, so Mallard on number 3 now. If I give her some power, she is now running. And that is the basics of Railmaster. Of course, there's a lot more to it. The program is capable of doing a lot more. For example, you can do handheld stuff. I've got my iPad hooked up to this, and I think for an extra £10 you can use a handheld device. But for all intents and purposes, that in a nutshell is DCC. So finally, there is one question that I get asked quite frequently, and people seem to be quite interested by this, and the question is, can you mix DC and DCC locomotives together? Now the honest answer is yes, it can be done, but generally I really don't recommend it. Now first of all, can you run DC locomotives on a DCC controller? Now normally not, but with the DCC select controller, by selecting 00 and pressing select, you can very rudimentarily control a DC locomotive locomotive on your DCC controller, but it's terrible for the motor. That motor has to deal with that 15 volt alternating current that we mentioned, and that is not good for it. So you shouldn't do that. You can with the Select. Most controllers don't allow it. The Select does, but I can highly not recommend it. Now the middle line here, where the Flying Scotsman's on, as you know, the Flying Scotsman is DCC fitted. That is now connected to a DC power supply, and most decoders will allow DC operation, although a lot of the time they don't behave as expected. For example, with the Hornby decoders, if I give this some power, you can see that they actually run very, very quickly. I mean, hang on, I think it's even derailed, it went so quickly. There we go. Let me just set it to, you know, a low speed. Look at the speed of that. Very, very fast. That is quite typical with DCC stuff. Equally with the TTS sound models, some of them don't even work at all when you try to power them on DC, so if you're trying to run a TTS model on DC you won't get the sound. You might be able to get them to move, but generally I would recommend de-chipping those just so that you don't damage the decoder. Some Bachmann models that are DCC fitted with a Bachmann decoder do work on DC. You have to sometimes enable it with a CV, one of the CVs, but I've got a couple of them that regardless of the direction you choose on the controller, they always go backwards or forwards or whatever, so you can do it, but it's not recommended. So there you have it, folks. That is my basic guide to using DCC. Obviously there's a lot to it and I couldn't cover everything, but basically those are my tips. If you're looking to get started, the cheapest controllers I know of are the DCC Select, and approximately at the same price actually is the E-Link with the Railmaster software. Of course that assumes that you've got a PC already that's near the layout that you can use. If you don't, then obviously that doesn't prove to be a cheaper option, but I personally had this PC lying around and so that wasn't a cost for me, but obviously bear that in mind. Railmaster is extremely powerful. There's not much that it can't do as far as I'm concerned. The Select is a much more simplistic little controller, but it actually does the trick. If you just want to run some DCC locos and you want to do some basic programming and stuff, then it's absolutely fine for the job. But for now, folks, that's all for today. I realise it's been a long one, so I'll leave it there. If you've got any questions, please feel free to ask me. And remember, the internet is your friend. If you want to know something, chances are someone else has been asking that in the past, and if you just look it up online, chances are you'll be able to find lots and lots of information about it. So don't feel frightened to ask. I'm more than happy to answer any questions. Obviously, I'm no expert when it comes to points and signals and things, so I'm probably not the person to ask when it comes to that kind of thing. But anything certainly with locomotives, what locomotives are suitable to be chipped. Obviously they don't have to be DCC ready, you can wire decoders in, etc. It's a little more complicated, but it can be done. Any questions along those lines, feel free to get in touch. But for now, folks, thank you for watching and I will see you very soon. Cheers everybody.